Good day, learners. My name is Mpoli Twaba, and today we will be dealing with mathematics. Thank you. And the topic for today is functions and graphs. And the subtopic, what I'll be concentrating on, is exponential functions. Now, we must understand the objective or the focus for the day for this lesson. So the focus for the day for the lesson will be the graphs of exponential functions defined by y is equals to b exponent x for two cases. And our two cases are b is greater than 1, and that is the first case. Our second case is b is greater than 0 but less than 1. And the second objective or the second focus of this lesson will be how to sketch functions defined by y is equals to a times b to the exponent x plus p plus q, where b is greater than 0 and b is not equals to 1 using the characteristics. Remember here, our b must not be equals to 1. And again, we'll be focusing on the characteristics of an exponential function. So this is very important. We must remember that we'll be focusing on the characteristics of an exponential function to say how does this graph behave, how does it change. Now on the characteristics, we'll be looking at the domain and range, intercept with the axis, asymptotes, intervals of which the function increases or decreases, the shape, turning point. When you're talking to turning point, we'll be looking at the maxima or the minima, and the interpretation of an exponential function. So when we'll be dealing with the two cases that I've just mentioned before, we'll be looking at the characteristics. Now, this is just a recap. It's a recap of grade 10 content, where we are looking at the basic exponential graph. And our basic exponential graph, it's y is equals to b exponent x, where b stands for a value, it's a constant. And our b is greater than 0, and b not equals to 1. We'll be looking at the first case. Remember, I explained that we have two cases. The first case, it's when b is greater than 1. So we are starting with that first case where b is greater than 1. We are simply saying where our b is positive. Now we start with the first example. Y equals to 3 exponent x. And why do we say our b must not be equals to 1? Remember, once our b is 1, we will simply have a straight line graph that will pass at 1. And that graph is not an exponential. So that is why our b has got that restriction to say b must not be equals to 1. So we will have an equation that passes at 1, and it won't be an exponential graph. Now, the equation that we are looking at is y is equals to 3 exponent x. Now remember, in our objectives, our focus is to look at all those characteristics to say, how does this graph function behave when we have these characteristics? Now, the first characteristic that we'll talk about is the domain. Now, the function of an exponential graph, it will take all the elements of the real numbers. It means our domain will be x, an element of real numbers. What's a domain? A domain is where the x values, the graph is defined. The x values where the graph is defined, which means the graph will define on the x values. Remember when we have a Cartesian plane, this is the x-axis and that is the y-axis. Now, when we're talking of the domain, we are talking about that axis. So we'll be talking about those values where the graph is defined. So the graph will be defined on all those from negative infinity until positive infinity. It's because that is why we are saying it will take all the real values. Now, what will be the range? Our range are the y values. Now, what are the y values? Y values where the graph is defined. So when we're talking about the range, we are talking about the y values where the function or the graph is defined. Now, what is our range? Our range will be on the y-axis. So when we're talking about the range, we are looking at the x-axis. Now, we are saying what will be our range? Our range will be y is greater than 0. It means the positive part, it's above the x-axis. Now, where is our x-axis? Our x-axis is here. So where will our function be? Our function will be above the x-axis. So that will be the range of the graph. So the range is y is greater than 0. Now the intercept. Remember, we have a system of axes that has got the x and the y. Now the y-intercept, when we're looking for the y-intercept, we put x0. We put x0, any number to the exponent of 0. Remember your exponential laws that says if I have 5 exponent 0 is equals to 1. So any number to the exponent 0 equals to 1. So we have y equals to 1. Therefore, the coordinates of the y-intercept will be 0 and 1, which means our graph will cut the y-axis at 0 and 1. The x-intercept. When we're looking for the x-intercept, we put y0. Now, when we put y0 on our function, we have 0 equals to x. We can't get any number that can make this to be 0. So we cannot get the x-intercept. So that is why we do not have the x-intercept. Though the graph will not cut the x-axis. It does not have the x-intercept. Now, our next characteristics. Remember, this is very important, very critical, because we're looking at the graph, how does it behave towards the characteristics. Now, we're still looking at that case where b is greater than 1. We have y equals to 3x. We're still working to the graph of y is equals to 3 exponent x. 3 exponent x. Now the asymptote. Our asymptote is the x-axis, which means our exponential graph will have an asymptote at the x-axis. It will have an asymptote at the x-axis. Now that x-axis, we can be able to write it in the form of an equation. When we write it in the form of an equation, it's y equals to 0. Hopefully we remember why is it y equals to 0. Remember on the x-axis, if I have -1, I have -2, I have 1, I have 2. The coordinates there, it's 1 and 0. The coordinates there, it's 2 and 0. So we can see the coordinates there, it's -1 and 0. We can see that always our y is 0. That is why when we write it as a form of an equation, we have y equals to 0. Because on the x-axis, y is 0. Now, is it increasing or decreasing? So the graph increases without bound as x approaches infinity. Now, x will approach infinity when it goes to the right. So as x approaches positive infinity, the graph will increase. Now, what is our shape? The shape is a continuous smooth graph. It's a continuous smooth graph. Now, turning point. no turning point. Very important. You should remember that an exponential graph will not have a turning point. So it will not have a turning point. There we are. Now that is our graph. It's our exponential graph. Now, to look at those characteristics that we've just mentioned, it takes all the real values of x. Now, this is our x-axis. So our graph will take all the real values of x. It will take all the real values of x. It takes all the real values. That is why we say the domain is an x, an element of real numbers. It takes all. So our graph is defined there. Now the range. We said the range is y is greater than 0, which means our graph will be above the x-axis. Now there is our x-axis. Our graph is above the x-axis. It is above. So that is a range. It will never touch that. Now what is our asymptote? Our asymptote is the x-axis. Y equals to 0. Remember, an asymptote is a line that the graph approaches. It will approach that line, but it will never touch it. There will be a thin line. It will never touch the x-axis. So that is our asymptote. So this is an asymptote. It approaches that line, but it will never touch it. And we said it's an increasing function. It increases without bound. We can see it goes up, it's going up. It's increasing without bound. As it go up, we have arrows, we will have arrows. So it is an increasing function. And remember, this is a curve. It's a curve, it doesn't turn. That is why we say it does not have a turning point. So the exponential graph does not have a turning point. So we can see all our characteristics. It doesn't touch the x-axis. That is why there is no x-intercept. It only cuts the y-axis, at which point? At 0 and 1. So it's an increasing function. So this graph is for our first case. Our first case of b is greater than 1. Together? Yes, we are together. Now, let's look at our second case. Our second case, it's b is greater than 0 and b is less than 1. Remember, on our objective, we said on exponential functions, we'll be looking at two cases. The first case, it's b greater than 1. And we've already spoken about the first case of b greater than 1. Now, our second case. Our second case is where b is greater than 0 and b is less than 1. So, which means now in our second case, the value of b is a fraction. Now, what kind of a fraction is that? It's an improper fraction. So, our b is a fraction. It lies between 0 and 1. Our first case, it was greater than 1. So any number that is greater than 1 was our first case. Now on this case, we are looking at a fraction. Again, we still talk of a restriction. Our b greater than 0 and b is not equals to 1. Now our next function is y is equals to 3 exponent minus x. Or we can write it as 1 over 3 to the exponent x. Here, remember your exponential laws. Remember your exponential laws. Our exponential laws, we say a to the exponent minus 1 is equals to 1 over a to the exponent 1, which is the same as 1 over a. So if I have 3 to the exponent minus 2, I will have 1 over 3 exponent 2. Remember? Or we can have it as 3 to the power of 2. So, I'm sorry for that. It's 3 to the exponent of 2. 3 to the exponent of 2. So that is why here we have 3, y is equals to 3 exponent minus 1, or 1 over 3 exponent x, because when we change the laws, we have 1 over 3 to the exponent of 2. So if I have 2 to the exponent of minus 2, I'll have it as 1 over 2 to the exponent of 2. So this we are applying the exponential laws. That is why we are able to change it to 1 over 3 exponent x. So our b is a fraction, and it's a proper fraction. Now, still again, remember the important things are our characteristics. How does the graph behave? How does it behave looking at those characteristics? Now here, we are looking at the second case. Remember, very important, our second case is b is greater than 0 and b is less than 1. That is our second case. Y is equals to 3 to the exponent minus x, or y is equals to 1 over 3 exponent x. That is the function that we are looking at. Now the domain. Remember, the domain are the x values where the graph is defined. So when we talk to domain, we always talking to the x values where the graph is defined. And you should always remember that our x values are on the x-axis. Our x values are on the x-axis. So this gives us the x values where the graph is defined. So our graph will be defined at x. It's an element of real numbers. It means it takes all those real numbers. It takes all those real numbers on the x-axis. It will take all those real numbers. Now the range. The range, y is greater than 0. Y is greater than 0. So where is y greater than 0? Above the x-axis. It's above the x-axis. Now our range for our graph for the second case, it's y is greater than 0. So which is above. So it will be above, but it doesn't touch the x-axis. The intercept, we have two intercept, the y-intercept and the x-intercept. Two intercept, remember, y-intercept and the x-intercept. It's because our system of axes has got the x-axis and the y-axis. Now, y-intercept, when we're looking for the y-intercept, we should always remember that when we're looking for the y-intercept, we put x 0. So we put x 0. Where there is x, we put 0. Where is our x? Our x was an exponent. So on the exponent, we put 0. So we have y is equals to a third to the exponent 0, or y is equals to 3 to the exponent 0. Therefore, y will be equals to 1. Now, what are our coordinates? Our coordinates will be 0 and 1. So what are our coordinates? 0 and 1. X is 0, y is 1. So those are the coordinates of the y-intercept. That is where our graph will cut the y-axis. Now, the x-intercept. We don't have the x-intercept because remember, when we're looking for the x-intercept, we put y0. For the x-intercept, you put what? 0? You put y equals to 0. Now, when we put y0, we'll have 0 equals to a third to the exponent x. So we cannot get the x, so therefore, we do not have the x-intercept. Next, the asymptote. The asymptote is still our x-axis. Remember, you should be able to represent it in both ways. X-axis, or when they say write it in a form of an equation, is going to be what? Y equals to 0. So if they don't say write it in the form of equation, you write it as x-axis, you still write. Or if you write it as y equals to 0, you still correct. But if you are supposed, or the question says, write the asymptote as a form of an equation, now you must write it as y equals to 0. Because remember, an equation must have a left-hand side, an equal sign, and a right-hand side. So when we write an equation, we have a left-hand side, equal sign, and the right-hand side. So that will be an equation. Now, is it an increasing or decreasing function? Now it is a decreasing function. So what happens? It decreases without bound as x approaches positive infinity. So as x approaches positive infinity, what happens to the graph? The graph decreases without bound. So it will decrease without bound. So what is the shape? Its graph is a continuous smooth graph. Turning point, no, and B, no turning point. So the graph does not have a turning point because it's a curve. Now, there is our graph. There is our graph. We can see the shape. The shape, there is the shape. Smooth and continuous. There'll be arrows there, there'll be arrows as it continues. So it's a smooth, continuous graph. Now, decreasing. As x increases, you'll check your y. As x increases, what happens to y? Y decreases. As x increases, y decreases. As x increases, y decreases. That is why we say it's a decreasing function. So it's a decreasing function. As x increase, y decrease. So it's a decreasing function. So what is the y-intercept? Cuts the y at 1. X-intercept, no x-intercept. Asymptote, remember the asymptote, the graph will approach that line, it will never touch. We can see it approaches, but it will never touch the asymptote, because the asymptote is that line that the graph approaches. And asymptote, the graph is not defined at the asymptote. So it will never be defined at that graph. That is why it's the asymptote. So that graph will just approach that line, the x-axis. In this case, it's the x-axis. Now it's a decreasing function. So we can conclude about the two graphs. When we have b is greater than 1, and when we have b less than 1, greater than 0. The two graphs. Our system of axes, x-axis, this is the x-axis, the y-axis. This is our origin. Now, b greater than 0 is an increasing function. So it's an increasing function. It increases without bound as x approaches infinity. So it's an increasing function. So it increases, and it's a smooth graph, and it's a curve. It doesn't turn. It's a curve, it does not turn. So it does not have a turning point. Now, where b is greater than 0 and b is less than 0, it's a decreasing function. Remember, it cuts the x-axis at y. Now, decreasing function, so it's a decreasing function. So it decreases without bound as x approaches infinity. So we can conclude about the two graphs. Or what is it that is similar? What is similar? We can see the domain where the graph is defined. Remember the x values where the graphs are defined. So both graphs, they are defined it takes all the real values. X is an element of real numbers. What is the range? Range is greater than 0. What is the y-intercept? The y-intercept is at 0 and y. X-intercept, both graphs do not have the x-intercept. And they are curves. They do not have turning points. The difference is that where b is a fraction, it's a decreasing one. Where b is greater than 1, it's an increasing function. So that is the difference between the two. That is the difference. So we can conclude domain, x an element of real numbers. Range, y is greater than 0. Asymptote, x-axis, or when we write it as an equation, is going to be y is greater than 0. Y-intercept at 0 and 1. Both graphs cut at 0 and 1. The difference, b greater than 1 is an increasing function. B greater than 0, less than 1, it's a decreasing function. So it's above the x-axis. That is our range. So we can conclude about the two graphs. Now, we are introducing parameter A. Now, what is a parameter? A parameter is a constant on an equation that defines its operation. So we are introducing a parameter. We are introducing a constant on an equation. So on this equation, we are introducing that parameter. So remember, we're still talking to what? To the same case. Our case is still b greater than 1. And all those characteristics on b greater than 1, that's still the same. Now we first look at the parameter where a is greater than 1 to say what will happen when a is greater than 1. When a is positive, is greater than 1. Now, what does a do? A makes the graph to lie above the horizontal asymptote. Now, when a is greater than 0, when a is positive, the graph will lie above the horizontal asymptote. Remember, we've seen those exponential graphs that they only have one asymptote, and that asymptote is a horizontal one. So it's only one asymptote, horizontal. So when a is greater than 0, the graph lies above the horizontal asymptote. It lies above the horizontal asymptote, or our horizontal asymptote, which is the x-axis. When we write it in the form of an equation, it's y equals to 0. It lies, and it will curve upwards, and it stretches vertically. It will stretch vertically. Now, let's look at the examples of those 4 graphs. F of x is equals to 3 to the exponent x. G of x is equals to 2 times 3 to the exponent of x. H of x is equals to 5 times 3 to the exponent of x. M of x is equals to 7 times 3 exponent x. Now our A here, parameter A is 2, 5, and 7 for those different graphs. For the graph of G, for the graph of H, and for the graph of M. We still remember those characteristics of that graph. The characteristics still hold because they are the ones that tells us how the graph behaves. And the parameter A is the one that will define and will tell us how the graph behaves. Remember, we said parameter A is a constant on an equation that defines a graph, or how will it, the operation, to say how will the operation behave. Now we have our A as 2 on G, A as 5 on H, A as 7 on M. Now there are our 3 graphs. The graph of H is the green one. The graph of G, the red one. The graph of F is green, of G is brown, of H is green, and we have the gray one of M. So what will be the domain? We can see the graphs are defined on all the values. The graphs are defined. They are defined. So they take all the real values. They are defined on the x-axis. So the range, y is greater than 0. The asymptote, x-axis. And what will be our y-intercept? We can see our y-intercept are different. Now, the second case. Remember, we've already dealt in details with the second case. We know that when b is greater than 1, it will increase. Now it's a decreasing one. Now we just look at parameter A to say what does it do. We said the graph will lie above the the horizontal asymptote. Again, it will lie above the horizontal asymptote. Now the horizontal asymptote, it still lies above the horizontal asymptote. The domain is still x, an element of real numbers. The range, y is greater than 0. Our asymptote, x-axis, as an equation is y equals to 0. The y-intercept, we can see our y-intercept. The graph of S will have the y-axis at 0, 1, y-axis at 0, 2, at 0, 5, and at 0, 7. So this is still decreasing because this is the case of b greater than 0, b less than 1. Now, what happens if a is greater than 0 but a is less than 1? Remember, still here a is positive. And we say when a is a positive, what does this happen? It lies above. The only thing is that the graph stretches horizontally. It stretches horizontally. Our a is a fraction. But remember, our b is still greater than 1. So it's still an increasing function. So we can see what is our domain? X, an element of real numbers. Our range, it lies above. Our asymptote, still the x-axis. Now, the y-intercept is the one that is different. Remember, it will be 1 and 0. We'll have 1, 0 and a half, 0 and 1 over 5, and 0 and 1 over 9. Because it is stretching horizontal. And it's still an increasing function because our b is greater than 1. Now, on the case of b greater than 0, b less than 1. Remember, on this case, it's a decreasing function. That is the only difference. So it's a decreasing function. Our a is still positive. Now, when our a is still positive, it lies above the horizontal asymptote. But when a is a fraction, what happens? Stretches horizontally. When it is a fraction, it stretches horizontally. But we still remember that it's a decreasing function. We can see it's a decreasing function because our b is between 0 and 1. Our a is a fraction. What will be our domain? Our domain, again, is still x, an element of real numbers. It's still x, an element of real numbers. What is our range? Our range is still y is greater than 0. What is our asymptote? Our asymptote is still the x-axis. Intercept, our intercept will differ because based on the a. For our basic graph there, we have 0 and 1. Then we will have 0 and a third. We have 0 and 1 over 5. We have 0 and 1 over 9. So that will be our y-intercept. Decreasing or increasing? Because our b is greater than 0, less than 1, we said when b is a fraction, a proper fraction, it's a decreasing function. We can see it decreases. So it still remains a decreasing function. Now, we can see that when a is greater than 0, it's greater than 1, is greater than 1, what happens? It lies above the horizontal asymptote. So it lies above the horizontal asymptote. It will lie above the horizontal asymptote. Now, what will be the range? Remember, the range is still y greater than 0. What will be our domain? X, an element of real numbers. It's still a decreasing function because our b is greater than 1. Still increasing. Y-intercept is still at 1, 0. At 0 and 1, at 0 and 1. Now, what happens when our a is negative? When a is negative, what happens? It lies below the horizontal asymptote. Lies below the horizontal asymptote. It will be below. So this is the graph. It is below the horizontal asymptote. But what does the domain remains? X, an element of real numbers. Now it was an increasing, it becomes a decreasing. What is our range this time? Our range changes. Why it's less than 0? Because the graph is defined below the x-axis. So it is defined. Remember the range? That is where the y values where the graph is defined. So it's defined there. So it's y is less than 0. What will be our y-intercept? At 0 and minus 1. So when a is negative, where does it lie? Below the horizontal asymptote. Even when our b, when our b, it's a third, it's a fraction, what happens? It's still a decreasing function. It's still a decreasing function. We are changing the A. The A is now negative. So the range still remains the same, but remember that's a decreasing one. Now what happens? If A is negative, it lies below the horizontal asymptote. It was a decreasing, it becomes an increasing. We can see it increase without bound. What changes? Our range. It lies below. The range is y less than 0. Y intercept 0 and minus 1, it's an increasing function. So we can conclude that. Now we introduce parameter Q. Parameter Q does what to the graph? Parameter Q shifts the graph up and down. So when Q is positive, the graph will shift Q units up when Q is greater than 0. So remember our two cases, we still look at the two cases. When Q is less than 0 negative, it will shift downwards. So Q shifts the graph up and down. So it means it changes the asymptote. So our horizontal asymptote will be y equals to Q. So Q always gives you the horizontal asymptote. Here our horizontal asymptote, remember, our horizontal asymptote was y equals to 0 because this graph is the same as y is equals to 3 exponent x plus 0. It's the same as 3 exponent x plus 0. That is why the asymptote was 0, y equals to 0. So the asymptote is 0. Let's look at the following function. So we are saying when Q is greater than 0, shift 2 units upward. Q less than 0, shift 2 units downward. Here we can see our Q is negative 2, Q is 2. So it will shift how many units? 2 units up. How many units? 2 units down. So let's look at the two functions. There are the three functions, I'm sorry. So our F is our mother graph. So G has shifted how many units? 2 units upward. H has shifted how many units? 2 units downward. Because our Q was 2, our Q is minus 2. It's minus 2 there. So our asymptote, what will be our asymptote? Our asymptote will be y equals to 2. Our asymptote is y equals to minus 2. Now what happens? The domain is still the same. The range y equals to 0. Y greater than 0, I'm sorry, y greater than 0. Asymptote, the x-axis. Now the asymptote will change this time. The asymptote is 2. Now what happens? What will be our range? Our range is y greater than 2. Now again, the Q assist you in getting the range. So the Q will always assist you in the asymptote and when getting the range. Because our A is positive, it lies above, therefore y is greater than 2 because the graph is defined above 2. Now this time it is above minus 2, which is our asymptote. So it lies above minus 2. So our range will be y greater than minus 2. Now, the second case where B is greater than 0, B less than 1. It behaves the same. Q behaves the same. It doesn't matter. If our Q is greater than 0, 2 units up. Q less than 0, 2 units down. Now our Q is minus 2, Q is 2. So it will help us in terms of the asymptote. So the Q gives us the asymptote. So that is why here our asymptote is y equals to 2 for this graph. Here our asymptote is y equals to minus 2. And in all the cases, I represent your asymptote as a dotted line. So we can see our asymptote. Asymptote, y equals to 2. Asymptote, y equals to minus 2. The domain, x an element of real numbers. The range will be different. The graph of G, what will be the range? Because it's above the asymptote, the range will be y is greater than 2. The orange graph, which has shifted 2 units downward, what will happen? Which is our H graph, y greater than minus 2, because there is our asymptote. Our graph is defined up there. But what still remains, it's a decreasing function. Because what is our case here? We are talking of the case B less than 1, B greater than 0. So it's still a decreasing function. Now, when it has shifted up and down, remember, part of the graph will be above, part of the graph. So if the graph has shifted downwards, what will happen? Part of the graph will be below and part of the graph will be above, but not the x-axis. Remember, here is the asymptote. So it's above the asymptote. So when it's negative, remember, it's below. When A is negative, it will be below the asymptote. Always when A is negative, it's below. So the asymptote, this time it's -2. So the graph, where is the graph? Below the asymptote. But when it has shifted upward, what will happen? Part of the graph will be above the asymptote. Here, it's an asymptote. And that part here, it's an asymptote. So it's the asymptote that determines the graph. Now, y is equals to a times b to the exponent x plus p plus q. We still have b equals to 1. So we are wrapping up the parameters a, p, and q. Now, b determines the shape. So always b determines the shapes. When b is greater than 1, it's an increasing. b greater than 0, less than 1, it's a decreasing. What does a? It determines where the graph lies. It will be either above the asymptote or below the asymptote. When a is positive, above the asymptote. When a is negative, below the asymptote. So a tells you, so when a is greater than 0, above the horizontal asymptote. When a is negative, where does it lie? It lies below the horizontal asymptote. So when a is positive, above the horizontal asymptote. When a is negative, below the horizontal asymptote. Now q gives us the horizontal asymptote. And again, remember, it helps us to get the range. Now, what does PQ do? Q shifts the graph left and right. Left and right. When P is greater than 0, graph shifts to the left P units. When P is greater than 0, it shifts to the left P units. When P is less than 0, the graph shifts to the right P units. So it depends on the P. P greater than 0, to the left. P less than 0, to the right, depending on what is the value of P. Now here, what is P? P is 1. So where will it shift? It will shift to the left. P is -2. Where will it shift? It will shift to the right. So the domain still acts an element of real numbers. What is the range? Range, because it's still above. Remember, it's the case of b greater than 0. What is the asymptote? Still the x-axis. Increase or decrease? It's an increasing, because what is our b? Our b is greater than 1. So it's still an increasing function. Now, as an example, to sketch the graph, remember we can analyze that equation. When we analyze that equation, what do we have? Remember, what did we say about A? We said A, when it's positive, the graph will lie above. Before you sketch, analyze, look at the question, look at the parameters to say, what do the parameters do? What do they do? Now, the parameter A, we said when it's positive, the graph will lie above the horizontal asymptote. Now, when we're looking at this equation, our parameter is A, it will lie above the asymptote. Now, what did we say? This is always gives our Q. It helps us to get the asymptote, and it helps us to determine the range. So it will determine the range. We already know our asymptote. We already know our range. And what do we know? Our B greater than 1. What do we know? Our graph will lie above, and it's an increasing because our B is greater than 1. This is the case of B greater than 1. That is the case. So what happens? It's an increasing function. So our asymptote already, y is equals to -2, because we get it from there. Y-intercept, remember y-intercept, we put x0. So what will be our y-intercept? Y equals to 6. So our coordinates will be 0 and 6. X-intercept, our x-intercept will be x and -2. It's a decreasing function because what happens? It's a case of b greater than 1. So our b is 2. And what is our p? Our p is positive. Our p is greater than 0. The graph will shift to the left. There is our graph. Always when you sketch a graph, advisable to start with the asymptote so that you know where graph lies. So there is our asymptote, which is -2. And our range, remember our range will be y is greater than -2. X-axis at -2 and 0. Y-axis at 0 and 6. Now, what's happening is an increasing function because remember, our b was greater than 1. Now, another example to sketch. Remember, advisable to first understand the equation, analyze the equation, look at the parameters, or what do they do. Remember, A lies above. We already know it will lie above the asymptote. What is my asymptote? It's 1. I know my asymptote will be at 1. Now, did it shift left and right? No, it did not shift left and right. Now, what is our asymptote? Y equals to 0. No x-intercept. What is our y-intercept? Our y-intercept is at 6, because remember, y-intercept, you put x0. Domain, x, an element of real numbers. What will be our range? Our range is y greater than 1, because remember, the asymptote helps you to get the range. Increasing or decreasing? It's increasing, because our b is greater than 1. There is our graph, and there is the asymptote. Remember asymptote? X equals to 1. So our graph is still increasing, and there is the y-intercept at 0 and 1. So it's an increasing function because our b is greater than 1. Another example where we are interpreting here, we must get the value of a, the value of b, the value of q. We are given that graph. Now remember, when given the graph and the equation, always analyze your graph before. Oh, I can look at my graph, there's my asymptote. It lies above the asymptote, which means my a will be positive because this graph lies above. So a should be positive. Already I have my asymptote because q represents the asymptote. And this asymptote will be able to help me to get what? The range. My range will be above because it's above. It's going to be y is greater than 1. So you first substitute your asymptote. So you analyze what you have in front of you before you could start so that you understand what is given, so that you can use what is given. So we first substitute our asymptote. There is our asymptote at y equals to 1. We substitute the asymptote. Now, we are given again the y-axis, the y-intercept. Y-intercept is at 0 and 3. So where we have x, so that's where the graph cuts the y-axis, and that's where the graph cuts that point there. So what is our x is 0. What is our y? Our y is 3. So we can be able to get a, and our a is 2. So we use the information that is given. Now we have another point there, which is 1 and 5. So we can substitute that point. Already we have our a, and we have our q. Now we have our q, which is 1. We have our a, which is 2. We substitute. We have another point, which is given as 1 and 5. So we substitute that other point, which is given to us, to get the value of b. So we already got a, we got q, and we have our equation. So which means our equation will be y is equals to 2 times 2 to the exponent x plus 1. So, and it makes sense. I is positive, it lies above the horizontal asymptote. So that's a small exercise. Given that equation, y is equals to a times 3 to the exponent x plus 1 plus q, and y is equals to 1. So it's a graph again, as I've explained. When you are given a graph and information before, analyze the diagram. Analyze the diagram first, and the information is very important to analyze. So you will analyze, you can see, oh, the graph lies below the horizontal asymptote. It lies below the horizontal asymptote. Now, when it lies below the horizontal asymptote, it means what will be my a? My a is going to be negative because it lies below the horizontal asymptote. And what is it that is given? I'm given that y is equals to 1. So what is y? It's my asymptote. And my asymptote is 1. So, which means it's q. Remember, we said q gives us the asymptote. So my q is 1. So it's my horizontal asymptote. And then what happens? We can see our b was 3. Now, but determine the values of a and q. The graph cuts the x-axis at -2. We have the x-axis. So it cuts the x-axis at -2. So we have a point there. And what do we have? We have the asymptote. So we've analyzed the diagram. We can see, oh, I have a Q, which is my horizontal asymptote. It lies below, and I have another point. The graph passes at that point. So I can be able to do what? I can be able to substitute that point of -2 and 0. My point is -2 and 0. That is the x-intercept of that graph. Now, we can be able, we substitute the asymptote. Remember, we're given that the asymptote is y equals to 0. And we could read it off the graph, and we could see it on the information that is given to us. So our asymptote is 1. So we first start by substituting the asymptote. Remember, we use the information that is given to us. Our asymptote is 1. We substitute. We're given another point, the x-intercept, where our x-intercept was -2 and 0. So we substitute that other point. And we substitute the other point. Where there is x, we substitute by -2. Where there is y, we substitute by 0. Then we solve for a. So this is just algebraic manipulation here. You do your algebraic manipulation. Remember your exponential laws again. 1, it will be -1, then our a is -3. So a is -3. So we're able to get our a, which is -3, and our q is 1. And it makes sense for our a to be -3. Why does it make sense? It makes sense because the graph lies below the horizontal asymptote. And we said when a is negative, the graph will lie below the horizontal asymptote. So it makes sense, reading off from the graph, to say, yes, it lies below. Therefore, that is why my a should be negative. That is why you have to analyze your equation. Look at the graph before you could do anything. Now, remember in grade 10, you had to reflect about the x-axis. When you reflect about the x-axis, you change y, you make it negative. So you will have y is equals to -3x. So it's reflecting. So it simply means it's the same as when we were making a negative. Remember, it's that. So it basically means we are reflecting about the x-axis. We are reflecting about that line, which is our x-axis. So you just make your y negative. Remember, in maths, you can't leave an equation as negative y. So you multiply that negative both sides, you have -3 exponent x. So you change. When you are reflecting about the y-axis, you change x to be negative. Change x to be negative. If your graph was y equals to 3 exponent x, reflecting about the y-axis, you'll have y is equals to 3 exponent -x. Can you see reflecting about the y-axis gives you the 2 cases? Because I'll have that graph. Now, when I'm reflecting about the y-axis, I have that. So it gives us those 2 cases. So when I'm reflecting about the y-axis, I'll have y is equals to 3 to the exponent -x. Now, it's a question that you can do. Remember, I said when you are given the equation, please analyze the question first. These are the questions that you can do. Now, this gives us a summary. Now, this gives us a summary. Our summary, remember our concentration was on the exponential graph. You still have to do those, but our concentration was on the exponential graph. Now, what does our summary say? Domain. For all the function, the domain will be x, an element of real numbers. X, an element of real numbers. If you have an exponential function, your domain will be x, an element of real numbers. Your function will take all the x values. Remember, domain is where the x values where the graph is defined. So graph is defined on all x values. So it doesn't matter whether it moves up or to the left or to the right, the domain remains as x element of real numbers. Now, where do you get your range? Remember, your range, you get it from the asymptote. Now, remember, depending on what your asymptote is and depending where your graph lies, looking at that value of A. So it depends on that. Asymptote, remember your Q. Your Q always gives you your asymptote. When Q is greater than 0, it means it has moved Q units upward. When Q is less than 0, it means it has moved Q units downward. So always your Q gives you the horizontal asymptote. Remember, an exponential graph has got only one asymptote. And remember that Q, again, helps you to get the range. It helps you to get the range. So Q plays two roles. It's an asymptote. It helps you to get the range, depending on where the graph lies. When it lies up, it means its Y is greater. When it lies below, it's less than. So it depends where the graph lies. If it lies above the asymptote, it means it will be Y greater. If it lies below the asymptote, it means Y less than. Now, our summary for P, parameter A, parameter P, and parameter Q. Remember, B is not equals to 1. Now, this is a summary for our parameters. We remember when Q is greater than 0, the graph has shifted upward. When Q is less than 0, the graph has shifted downward. When P is greater than 0, the graph has shifted to the left. When A is less than 0, the graph lies. So when it lies below the asymptote, it means A is negative. A is negative. When it's A, it lies below the asymptote, A is negative. We can see these two graphs, they lie below the horizontal asymptote. A is negative. They lie above the asymptote. A is positive. A is positive. Q positive, it has shifted upward. Q, it's negative, it has shifted downward. Now let's look at P. P here, it's less than 0. Here, P was greater than 0. P is less than 0, it will shift to the right. We still look at A less than 0, A greater than 0. And our Q's are here. Q greater than 0, Q less than 0. When A positive, below. Remember? A positive, below the asymptote. A positive, below the asymptote. The only thing, Q positive, it has shifted upward, depending on the units of Q. Q negative, it has shifted downwards. A greater than 0, it's positive, it's above. Here, remember, A was negative, it's below. A negative, below. A positive, greater than 0, above. A positive, it's still above. So our A always, it means when it's negative, the graph will lie below the asymptote. When A, it's negative, it lies below. When A is positive, it lies above. A negative, below the horizontal asymptote. A positive, above. Q shifts the graph up and down. Q will shift the graph up and down. When Q is positive, the graph will shift upward. When Q is negative, the graph will shift downwards. When P is positive, greater than 0, it will shift to the left. When P is less than 0, it will shift to the right. So those parameters tells us about the behavior of the graph. But we are able to see that our characteristics will remain the same. Remember, the domain, X, an element of real numbers. Q, again, remember that our Q, what does it help us? Q, again, helps us on the range. It gives us the domain, but it helps us to determine the range. So if it lies below, it means it's going to be Y less than. Lies below, it's going to be Y less than, depending on the asymptote. Y, when it lies above, Y greater than, above, y greater than, below, y less than, below, y less than. Thank you very much for the lesson, and thank you.